Types of range extender. The range extenders for electrical vehicle can be classified as IC engine based range extender, fuel cell range extender, pre-piston linear generator, FPLC range extender, micro gas turbine range extender, and there can be also battery based range extenders. The IC engine based range extender can be seen into this figure. So the IC engine based range extender is a version of PHEV, that is a plug-in hybrid electric vehicle, where the fraction of energy derived from the electric source is higher. The difference between the range extender from other hybrid electric vehicle is that there is no mechanical link between the engine and the wheels, or the range extended IC engine is not driving the wheels. Rather, it is only providing supply to charge the battery, or it works as a generator. The IC engine used is generally compact and lightweight with its integrated generator. So the generator is the important parameter or component. Simply charges the battery as necessary and extend the range of the vehicle. As shown here, this is the battery and which is supplying to the electric motor, and it is connected to the transmission and given to the wheels. And we can see the range extender is here, which is the IC engine, internal combustion engine, and only the supply is given here. It is not connected to this loop to the transmission. So the range extender, which is IC engine based, is coupled with the generator, which is electric machine is a generator, and is give supply through the inverter to the battery, or it may give directly to the motor for the transmission. So here the magnified view of this range extender is shown. You can see the IC engine, which is providing generated output. Three-phase generated output is shown here, which is the AC. Now it can be converted to DC and connected to the DC link, and then it can go to the battery or to the drive. So in a plug-in hybrid electrical vehicle, the IC engine directly supplies power to the wheel, but in the range extender, IC engine works as a generator and gives supply to the battery. In this figure, it can be seen that the REV, that is the range extended electrical vehicle, lies between the battery electric vehicle, that is a fully electric drive or battery electric vehicle, and PHEV, that is full electrification and partial electrification can be seen at the both sides of the extended electrical vehicle. So it lies between these two, BEV and PHEV. Here we can see the equations for this IC engine based range extender. The total energy E load, that is flowing from the range extender to the load or to the drive, can be calculated by using the equation, that is E load is nothing but the energy supplied by the range extender, and it gives energy supplied from the battery. So ERE is energy provided by the range extender. Alpha is the percentage of the energy flowing from the range extender to the battery pack. Beta is the percentage of the energy flowing from the range extender to the boost converter. Eta bat is the energy conversion efficiency of the battery pack or efficiency of the battery. Eta DC is the energy conversion efficiency of the boost converter or efficiency of the boost converter. And eta AC is the energy conversion efficiency of the inverter or efficiency of the inverter. We can see this equation also here. So considering the battery connected to the load through this DC to DC converter and DC to AC converter, now we can see the range extender is connected to the battery side or to the battery here. Now the energy flowing from the range extender is ERE, which is flowing. Now the portion of that flowing to the battery is alpha into ERE, and part of it is flowing is beta into ERE towards this DC to DC converter, so it can be split to the batteries in this side. Now the energy which is flowing from the battery can be considered as alpha into ERE, this portion, into how much is the efficiency of the battery. That portion you can consider. The efficiency of battery is eta battery. Now the portion which is flowing from this range extender to the load is beta into ERE. So beta into ERE, alpha ERE into eta battery is flowing to this. So these both can be going from this. So it can be written as alpha ERE, the energy flowing is alpha ERE into eta battery plus beta ERE, and again the efficiency of the converter efficiency eta DC has to be multiplied. That portion is flowing here. And finally, we can see it is the coming to the load. So up to this, we can calculate E load is equal to E energy of the range extender into alpha into eta battery plus beta, and we just simplified into eta DC into eta AC has to be considered finally, which is coming here. Up to this, it was the portion multiplied by the efficiency of DC converter. Here we have to multiply by the efficiency of the AC converter also. So this is how we can calculate the range extender energy when it is connected toward the battery side. The second is fuel cell as the range extender. So it can be seen that fuel cell are the devices that transform chemical energy into electrical energy by using hydrogen and oxygen and producing the electricity and forming heat and water as the byproducts. So here you can see the hydrogen tank will supply hydrogen to the fuel cell stack, and oxygen is also provided, and it will produce the electricity to charge the battery, and then it can be given to the drive. Fuel cells are mainly categorized into 5 types based on the operating temperature material used. The first is alkaline fuel cell, second is the solid oxide fuel cell, third is the phosphoric acid fuel cell, fourth is the polymer electrolyte fuel cell, and fifth is the molten carbonate fuel cell. Fuel cell have practical efficiency of 30 to 38% and theoretical efficiency is higher, it is 80%. Fuel cells are currently seen to be more viable and they are used in range extender purpose than a fuel cell electric vehicle because of the cost and safety of the system. So to use the fuel cell as a range extender is more economical than going for the full fuel cell EV at present because of the cost. The advantages of fuel cells are fast refueling, fast startup capability, low noise and vibrations, good driving range, compact size, low weight, and also the fuel cells have high energy efficiency and low emissions, which results into less pollution. In addition, there are some disadvantages. The high pure hydrogen is required for the fuel cell to work at maximum capability. Scaling fuel cells require creating a fuel tank from multiple fuel cells to maximize their lifespan. reliability, and power output. However, stacking multiple fuel cells can result in lack of structural integrity and non-uniform potential. Fuel cell based range extender can be seen into this diagram. So hydrogen is supplied here, air is supplied to the anode, and hydrogen to the cathode you can see here. And formation of the H plus ions will be there and it will pass to the electrolyte, forming the electricity, that is release of the electrons and formation of the water and heat. Now the generated electricity can be given to the DC to DC converter and then DC link. So the range extender can also be connected to the DC link here as shown in figure. In this case, the energy consumed by the load can be given by E load is equal to energy of the range extender into alpha into eta DC square into eta battery plus beta into eta AC. The same is explained here. Now the range extender is connected to the DC side here. Earlier it was connected to the battery side here. Now it is shifted to this. Now because of this, there will be changes into the energy or power flow equation. So this is the battery. Now from this range extender, it will have alpha into ERE energy, part of the energy which is supplied to the DC to DC link via the DC to DC link to the battery. And second, it will be supplied to the DC to AC link and to the load. So here part of alpha RE will be diverted here to the battery and beta RE will be given to the load. Now considering the efficiency of the DC converter, it will have alpha ERE into efficiency of the DC will flow to the battery. Now from this alpha ERE into eta DC into efficiency of the battery, considering the efficiency, eta battery will flow towards this DC to DC link from the battery. Now, considering the efficiency of the DC converter, it will be alpha ARE into eta DC square because earlier there is eta DC term which is sent to this battery and now it is coming from this DC. So eta DC will be multiplied. So it will be eta DC square into efficiency of the battery, that is eta battery. Now these two will be supplied at this end, which is coming directly from the range extender, which is coming from the battery because of the range extender input. And finally, this will be multiplied with the eta AC, and that will be E load. So you can get the equation here as E load equal to ERE alpha into eta DC square into eta battery plus beta into alpha AC. So this is alpha AC has to be multiplied to this summation of alpha ERE into eta DC square into eta battery plus beta ERE and multiplied to the alpha AC as shown into this figure. If the total energy from the range extended flows to the load, the range extender should be connected to the DC link in order to increase the overall efficiency. So when the purpose is to completely supply to the load, then it is better to connect this range extender to the load side. And that is the most efficient way. It is preferable that the battery pack keeps its SOC during the extended range, that is a driving stage. The energy used to charge the battery pack from the range extender would finally move to the load in which process the energy conversion efficiency is reduced.